Hi there and welcome to Hegarty Maths. It's Mr. Arnold here and this is the third video on integration. We'll be focusing on simple definite integrals and it is geared towards A-level maths but is applicable to most other exam boards. Okay, so in previous videos we've looked at indefinite integrals, and when we've done indefinite integrals we've always had to include a constant c. Well, in these examples and for this video we're going to look at definite integrals. And if you're familiar with your differentiation, it's a little bit like evaluating the derivative at a particular point. So we're going to need this formula here and we're going to apply it to this example. So just like before, I'm going to evaluate the integral of 4x minus 1 with respect to x. So the integral I is going to equal, I'm going to increase the power by 1, which is going to give me an x squared and multiply by 1 over 2. So 4 times a half is 2, and the integral of negative 1 is going to be negative x. Now the key thing here is that when we integrate the function, we're going to put it in square brackets because it's a definite integral and we need to evaluate it at the values 1 and 3. So the next part is we're going to substitute the value 3 into this function here. So we get 2 times 3 squared minus 3. And what we need to do is we need to subtract the lower bound. So we're going to subtract and then substituting the 1 back in. So we get 2 times 1 squared minus 1. Okay, so 3 squared is 9, 9 times 2 is 18, and 18 subtract 3 is 15. So we're working the inside of these brackets here. And I need to take away from that, 1 squared is 1, 1 times 2 is 2, and 2 subtract 1 is 1. So we're taking away 1. So 15 subtract 1 is 14. So just a quick recap there. We integrate as normal, but we don't need the constant of integration c. And then what we do is we substitute the value 3 in for our x. And then we subtract and then substitute the value 1 in to the function. And then we evaluate that and we get an answer. Let's have a look at a second example here. So we've got a function 3x plus 1 all squared, and we need to integrate this between the values 3 and 2. Well, the first thing I'm going to do is I'm going to tidy up this function here. So expanding this out, we get 9x squared plus 3 times 1 is 3, and then double it, 6x, and we'll have a 1 at the end, and that's with respect to x. So let's work out the integral now. So I will be equal to, and again we're going to use square brackets here and integrate the function. So increasing the power by 1, we get a 3. I need to multiply by 1 over 3, so 9 times 1 over 3 is 3. Plus, increasing the power by 1 here, we get a 2. Multiplying our 6 by 1 over 2, 6 times a half is also 3. And increasing the power of x by 1 here is going to give me x. And we need to evaluate this integral between the limits 2 and 3. So, I'll just take out the highlighter here, just so we can be a little bit clearer about what's going on. So I'm going to take this 3 and substitute it into the function here. So we get 3 times 3 cubed plus 3 times 3 squared plus 3. And then what I'm going to do is, I'll just highlight all of this. I'm now going to substitute in the lower bound, which is 2. So substituting the lower bound in, and we're going to take that away. So we're subtracting and then putting this lower bound in. It's handy to leave up brackets here, just in case. So 3 times 2 cubed plus 3 times 2 squared plus 2. So that was the lower bound. So you put the upper bound in and you subtract the lower bound. And we'll talk about what the purpose of this is in a moment. So let's just tidy this up. I'm going to keep the brackets up for the time being. 3 cubed is 27. 27 times 3 is 81. 3 squared is 9. 9 times 3 is 27. And we need to add on 3. And then I'm going to take away 2 cubed is 8. 8 times 3 is 24. 2 squared is 4. 4 times 3 is 12. And adding on that 2. Let's see, 3 and 27 is 30. And 81 is going to give me 111. And I need to subtract from 111. 12 and 24 is 36. And we had a 2 here. 36 and 2 is 38. And then what we need to do is do 111 take away 38, 73. And that's the solution. Okay, one more, and then we'll talk about the purpose of the definite integral. So example 3 here, similar to what we've been doing before. And you'll notice that we have an integral like so. I'm going to tidy up so it's a little bit easier to work with. So the integral between -1 and 2 of, now let's split this into 2 fractions. So 4x to the power 4 over 2x subtract x over 2x, and we're integrating that with respect to x. I'm going to do a little bit more work on this now before we go ahead. So integrating between -1 and 2. 4 over 2 is 2, and x to the power 4 over x is x to the power 3. This 2, this dividing by 2, I'm going to take out and write it as timesing by 1/2, and x over x is 1. And that's with respect to x. Okay, so I will be the integral, and open the bracket. So integrating 2x cubed, increase the power of x by 1, multiply by 1 over that power. So 2 times 1/4 is 1/2. And when we integrate -1/2, we get -1/2x. Okay, we're going to integrate this between -1 and 2. Right, so like before, we start by putting in the upper bound. Let's change colour because I had a different colour in the last one. So we're going to take this upper bound and put it into the integral. So I'm going to put up a pair of brackets to prepare and protect the function, if you will. So we do 1/2 times 2 to the power 4 minus 1/2 times 2, and close off those brackets. We're going to take away the lower bound evaluated. So we put the upper bound in, which is this part. Now you'll see the reason why I put this bracket up here in a moment, why it's useful. So now, yeah, putting in this lower bound into the integral. So we get 1/2 times -1 to the power 4 minus 1/2 times -1, and close that off. So that was our lower bound gone in. So evaluating the integral at the lower bound, evaluating the integral at the upper bound, and subtracting. upper bound comes first. Okay, let's tidy this up now. 2 to the power 4, it's going to be 2, 4, 8, 16. 16 times a half is 8. And a half times 2 is 1. And I need to take away negative 1 to the power 4 is 1. 1 times a half is a half. And negative a half times 1, negative 1 is going to be positive a half. Which is going to give me 7 subtract 1, which is 6. Okay, so what is the purpose of the definite integral? Well, it's all about finding the area trapped beneath the curve. So if I have some function f of x and I want to know, well, what is the area between these two values on the x-axis? So if I wanted to know what is this area here that's trapped beneath the curve, what we can do is work out the integral of f of x with respect to x between b and a. So if we integrate the function with respect to x and evaluate it between the values b and a, that will tell me the area trapped beneath the curve. So when we differentiated earlier on in different videos, that allowed us to find the gradient of the tangent to the curve. Well, integration helps us find the area beneath the curve. Let's see it in action here. So I've got a function here, and I'm asked to find the area of the region enclosed by the curve y equals f of x, the x-axis, and the given ordinates. So if I want to find the area trapped beneath the curve when x equals 0 and x equals 2, in fact, let's draw up this function so we can see it on Desmos. Okay, so here's what we have here. This is the function x squared plus 2, and these are the we want to know what is the area trapped beneath the curve when x equals 0 and when x equals 2. Now notice it only works out the area beneath the curve as far as the x-axis. Now if I was just looking at this picture here, I would assume that the area is roughly around, let's see, 1, 2, 3, 4, 5, probably 6.5, maybe 7, between 6.5 and 7, something like that. Let's see if integrating will calculate that for us. Okay, so what we're going to do is we're going to integrate. We're going to integrate between 0 and 2 the function x squared plus 2, and we're integrating with respect to x. So, like before, I'm going to put up big brackets. We're going to increase the power of x by 1, multiply by 1 over that power, increasing the power of x by 1, and we get 2x, and we need to evaluate that between 0 and 2. Okay, so let's first of all work out the upper bound. So we get 1/3 times 2 cubed plus 2 times 2. That's the upper bound done. Now let's do the, there's our upper bound. We're going to do the lower bound now. Or the upper limit and lower limit, as they're sometimes called. So the lower limit, we're going to get 1/3 times 0, which is 0. 0 cubed plus 2 times 0, which is all going to work out to be 0. Luckily, so when we put in this lower limit, we're going to end up with 0. So let's check out what we get here. Well, I did guess that we would get something between 6.5 and 7. Let's see, we get 2 cubed, which is 8, so that's 8 over 3, plus 2 times 2 is 4, which is 4, Now 8 over 3 goes in 2.2 and a third. We get 2 and a third plus 4 gives us 6 and 2 and 2/3, should I say, 6 and 2/3. I said between 6.5 and 7, not too far off at all. So 6 and 2/3 squared units. One more example to do. So again, finding the area of the region enclosed by the curve, the x-axis and the given ordinates. So what we're going to do is we're going to integrate. I will be our integral. We're going to integrate between -5 and -1. -1. We're integrating 3 plus 5 over x squared with respect to x. First thing I'm going to do is just write this in a slightly more manageable form. So between -5 and 1, it's going to be 3 plus 5x to the -2 dx. Okay, so let's integrate first of all. I should be putting up squared brackets here because we're going to evaluate this integral. Okay, so increasing the power of x by 1, we get 3x here. Plus increasing the value of x, we get x to the power of -1. Multiplying by 1 over -1 is going to give me -5. So -5x to the -1. We need to evaluate that between -5 and -1. So what we need to do is first of all put in the upper limit. 3 times -1 minus 5 times -1 to the power of -1. And close it off. And we're going to subtract the lower limit. So 3 times -5 subtract 5 times -5 to the power -1. Now this is a Core 2 exam or Core 2 topic, so you can use your calculator to do this. Let's see, I'll try and do without. 3 times -1, -3. -1 to the power -1 is the same as -1. -5 times -1 is +5. I need to subtract 3 times -5, -15. -5 to the power -1 is -1 over 5, and -5 times -1 over 5 is +1. That will give me 2. Subtract -14. And subtracting a negative is the same as adding, so we get an answer of 16. Right, and that's it for this video. Hopefully you found it useful. I'll be back again with another video soon. All the best.